Hi there. I don't think we've spoken to such a large crowd, so this is exciting for us. We've come to talk to you about extreme programming. My name is Rachel.
I'm Vikki. I'm a developer and a team lead at Unruly.
And I am an Agile coach, and I will work across 4 teams at Unruly. And Unruly is a video advertising company, but we're not going to bore you about what we actually do. The company is quite interesting because it was founded in 2006 as a very small startup using extreme programming techniques. And 9 years later, we're still using extreme programming as the kind of the core of how we do things, and we've just been acquired. So it's kind of the story of a successful startup.
So whenever we talk about extreme programming, I think a lot of people get a picture in their head of something like this guy. So we wanted to kind of clarify what we meant by extreme programming.
So if you look at the picture, it's actually a picture of this sport called extreme ironing. There is no ironing involved in extreme programming, but there is the idea that you have practices that keep you safe. So, and what we're all about is trying to deliver solutions quickly but safely. So there's a bunch of XP practices, and this is just kind of a word cloud of some of them. And we were very much trying to think what's the unique parts of extreme programming. So there are a bunch of practices which are now kind of mainstream agile methods, and we're not really going to talk about those practices. And instead, what we're going to talk about is pairing, test first, and continuous delivery.
So the key thing about what we wanted to talk about was that we wanted to give you stuff you can take away and incorporate into what you're already doing. So the idea here is not that you kind of become extreme or anything like that. It's more about adopting the bits of these practices that work for you and getting them into what you're already doing. So we thought we would start with pairing. So I wanted to see who's already tried pair programming. If you can put your hands up. Cool. Yay. So that's lots of you. Great. Who has seen Pacific Rim? Okay, less of you. So if you've seen Pacific Rim but you don't know what pair programming is, you're already off to a good start because that drifting in Pacific Rim is very similar. For the rest of you, pair programming is basically 2 people working together at one computer working on code.
And the way that we practice pair programming is that basically all production code is developed by more than one person, so pairing together, sitting at a workstation. And when you are pair programming, it's quite a fluid way of working, so you're collaborating together and discussing design decisions and what you're going to do next. There are 2 roles, the navigator and the driver. The driver is the person at the keyboard, and they're the kind of person that's going to type the next words, and you've got the navigator kind of thinking, what should we do next? But you're not stuck in these roles, and you actually switch quite fluidly between them. One thing that's perhaps unique to where we work is that we try to switch pairs every day. So we're not stuck pairing with the same person day in, day out. And what we are trying to do is to make sure everybody's exposed to the code.
So what's brilliant about this is that it allows to share the knowledge between everybody on the team. So what can often happen in more traditional environments is there's like the one guy who understands how this feature works. And if they're on holiday or they leave, or maybe they're at a conference and you get a big bug, there's potentially no one around to fix it, or it's quite inconvenient to get it sorted. What's great about switching around pairs all the time is that far more people in the team understand how the feature works because more than one person has been involved with the development of it. And the idea there is also that we're all responsible for how the code works. So yeah, we even pair on fixing our presentations when they go wrong. So some of the other great aspects of this are that we make best use of the team expertise. So this allows us to kind of use everybody's skills to their fullest. So if we have someone who understands Java and someone who understands JavaScript well, we can, if we're working on a feature that crosses both of those, we can make the best use of everybody's abilities. One of the other really handy things is that if you've got somebody sat next to you, they can sanity check all of your ideas. So I imagine a lot of people have been in the scenario where they've had what seems like a really good idea, A day later, they figured out that it was actually kind of a waste of time. It was a bit of a rabbit hole. So if you're sat next to someone who can sanity check what you've been thinking of trying, you avoid all of that and you save a lot of time. And they're also there to just spot bugs in your approach and help you out. But a lot of you have already tried pair programming, which is great to see. So we also like to take this to an even more extreme level. So we have been practicing for about a year an extreme programming practice called mobbing or mob programming.
And what mob programming is taking that driver navigator idea, but bringing it to a team. So we have a team working at one workstation, big screen. Most of the people are sitting around the screen, and we have one keyboard to the side with a smaller screen. And we rotate in who is the driver and the navigator, the driver. So the team, the mob, they're the navigators, and they are doing the talking, and the driver is doing the typing. And what we do is run a timer so that we are actually making sure that we switch in and out of doing that at an even pace. Now, I don't know, has any of you been to a coding dojo where you've kind of had like a keyboard at the front and people have kind of rotated in to drive in that kind of situation? Don't know if there's
one person over there.
One person over there, two people. Few people. It's like that, and you can do it in a meeting room setup, but what we have done is we do it in our open workspace, and we have quite large screens and quite a lot of space around the desks. So we don't do it in a special environment. It's actually kind of just in our normal dev environment.
So what we found is that this doesn't fit all of the work that we do. It's best for really complicated stories. So the best example I could give you is that as we've grown, we went from being one massive team, well, I say massive, 6 people, to, that's big for us, to 4 teams of maybe between 4 and 8 people. So some of the responsibilities have been spread out between the teams. So this means that not everyone in the department understands everything that the other teams are working on. So if we have some code where maybe it's an API and one of the teams produces it and another of the teams is consuming it, if they work completely separately, some of the implementation and some of the understanding of how the API is meant to be used can get lost. Mobbing's great at this point because you can have 2 people from the consuming team and maybe 2 people from the producing team sit down and work together. So any misunderstandings are communicated at the time, and they can work together to resolve things quickly. So it works really well for that kind of story. But that said, you can have too many people. So we found that maybe 3 or 4 people works the best because, like Rachel says, if you switch around every 10 minutes, that might mean that it's 40 minutes between each of your goes, and it's really easy to get distracted and like go on Twitter or email or something, and you lose all of the benefits of a bunch of people being engaged and working together. So yeah, we found 3 or 4 people to work well. Another benefit of there being more than 2 people is that you can have kind of a rolling mob, which is where the picture. So as we've grown, we've had more meetings because we've got more to talk about. I'm a team lead, so I often end up having to go to meetings and leave my pair by themselves, so that means that the work has to stop. The nice thing about a mob is that the work can carry on, so I can leave, I can go to a meeting, and I can come back into the mob later on and pick up where we left off. So the work's always going. But saying that, this doesn't work for everything. Sometimes we get stuck, and if we don't know how to move forward with the work, the mob doesn't really work at that point. So what can work better is to split up and do some investigative work by ourselves.
So I don't know, has anybody seen this Will It Blend guy? Right, so what he does is he has a blender, and like obviously the videos are advertisements for the blender, but he shows himself trying to test the blender out by blending all sorts of obscure things like a tablet or also like weird things. Anyway, the point being is that sometimes you don't know whether something's going to work unless you try it out, but you're probably not ready to say, hey, we're going to really invest a lot of effort into this until you've tried it out in a small way. So what we do is we implement spikes, and these are typically solo. So a mob might split out, and people will go and do some investigative work before we decide to turn something into production code. So we, And it's called a spike because you're like driving a spike from the front end to the back end, and you're only just implementing a small piece of each layer. So you're trying to prove out an architectural design idea before then bringing it back, explaining it to the rest of the team, and then going away and implementing it.
It's worth pointing out that spikes are usually pretty hacky, and the code that is produced from a spike is actually thrown. So a lot of people think this is weird because the purpose of a spike, you're basically trying to find out if it's possible to do something and how you might approach the problem. But you'll often get to the point where you have something working. So people often ask, why would you then throw away what's working code? And the reason is that it won't be paired on. It will be rushed. It will be hurried. It probably won't be that well written. It'll be hard to understand. And the purpose isn't to make something that works. It's to understand the problem better. So once we have a spike and we understand the issue, we would then go back to pairing and testing our code and generally writing production quality code. And that often means that that second chance improves the quality of the code that actually winds up in production. Another thing about people working by themselves is it messes up the idea of shared ownership. So we've mentioned several times that we're keen everyone in the team understands as much of the code base as possible, and there's not one single person who understands something. So if someone's working by themselves, we lose that. So we're really keen that a code is paired on and well understood by everybody.
So we don't use code reviews, and one of the reasons we don't use code reviews is because a code review process causes a longer delay before your code is actually ready to release. So I'm sure that you've been in the situation where you've written some code, it then lies around waiting for somebody to review it, they review it, then their suggested changes lie around waiting for you to implement their changes, and eventually it gets, it's ready to go. And because we're concerned that we want to reduce the time between when we write code and when it's ready, we write all our code in pairs, and we don't go for this kind of review after way of working. So we're going to switch tack now and talk about another XP practice. Now, one of the things that's really cool about the Angular community is that you're already very invested in writing tests. You've got good test support in your tools and your framework. In extreme programming, we're not only writing tests, but we're usually writing our tests first. So we try to approach the way that we add changes into our code base by thinking, what would be an automated test that would prove this behavior is not there already? And I will implement that test. I will run that test to check that it isn't there already. Then I will implement the code. And so what we're doing is we're building the code up very slowly through a little step at a time.
So as Rachel says, we know a lot of you will be testing, so you'll know all of these benefits. Tests can obviously give you the confidence to deploy and deploy regularly, and we'll come back to why that's important to us. It can also give you the confidence to refactor. So if you've got an automated way of checking that your code is still doing what you thought it was, you can invest the time to keep improving the quality of the code without worrying that you're going to break something. And we're also there going to avoid manual mistakes. So as web developers, we know that we are going to be testing our stuff in a lot of disparate environments. And acceptance testing can be tough, but it's really, really useful to avoid the kind of boredom and then potential manual mistakes that you'll get from writing tests.
And as I was saying before, really, by writing the test first, you're really guaranteeing that you've got a test you add, but it also keeps your focus on what are we building now versus what might be useful in the future, or getting kind of distracted or diverted from the task in hand. So we think that working test first helps keep you focused on now, and then one of the other practices that can really help with this is to drive the behavior from the outside in. So writing the acceptance tests before you write the unit tests right in the middle.
So this is something we're really keen on. So once we're starting work on a feature, we make sure that we understand what we're supposed to be doing. That's obviously very important. But once we can define that well, we will create an acceptance test that sort of codifies the behavior that we're hoping to have achieved once we finish the implementation. And that acceptance test, or several acceptance tests, will help us focus our implementation and make sure that we don't make anything that we don't need. So it will guide which unit tests to write next. So we keep writing small unit tests, incrementally creating the implementation, and then going back to the overall acceptance test and seeing, are we getting closer to fulfilling what we were trying to do in the first place? So another thing that tests really help us with, and that I've kind of alluded to already, is continuous delivery. So what we mean by this is that our code's always ready to be deployed. We never commit anything that isn't ready for production. And that doesn't mean that we don't commit very often. We actually commit like maybe 10 times a day, potentially, and we extend this to mean that we also deploy several times a day. So this is great, and this means that we can go on a small piece of work from the implementation to having it live in our real production systems in a matter of hours sometimes. And
some of the things that we do that might seem extreme is that we do not have any manual testers. There's nobody else who's really heavily on these automated tests. We also don't have a kind of staging environment that code is going to between workstation to live. So we're keeping our development pipeline really short.
But whilst we try really hard to have comprehensive tests, loads of acceptance tests and loads of unit tests, we will always inevitably miss some things. So, there'll just be things that we didn't think of, things that are particularly challenging to write a test for, and there'll be differences between our test environment and our production environment. So we use monitoring to help us work around that and have it not put us off regular releases. So what this means is that we have various automated checks and monitoring and graphing systems. So we'll have screens in our development area, not dissimilar to this, but not quite as cool, that give us graphs of performance over time and allow us to be alerted when there are errors we weren't expecting or any kind of unforeseen problems, anything that we could have missed. And the great thing about these is we've got them hooked into our email systems, and they can text us outside of the office, so we have like 24/7 coverage to let us know that things are working as we expect. This kind of goes hand in hand with another one of the approaches that we use to facilitate constantly releasing. So it's one thing to know that everything's working, but if you find out that it isn't, you really want to be able to do something about it. And ideally, you want to prevent anything going wrong in the first place. So as I mentioned, we're always committing to master. We don't have feature branches at all. So everybody's code is continuously going into the main branch. So in order to avoid this being a problem, we've decoupled release from deployment. So what I mean by that is that our new code is going directly into production, but it's not necessarily going in front of the end users. So the code is always being released, but we use feature toggles to turn off new features until they're ready. So we use tests to make sure that we haven't broken what was already there, but we can avoid putting the new features in front of people until they're ready by having them behind these feature toggles. So we can roll out a feature when it's off. We can slowly roll it out to kind of friendly users. Maybe that would be beta testers for you. Or we can roll it out to incrementally, so maybe 1 in 10 users, and use monitoring to work out when it's ready to be fully released.
So if you're wondering what a feature toggle looks like, here's a bunch of feature toggles. They're kind of little flags, kind of going on, off, on, off, on, off. We do not keep them there forever. What we do is we introduce a new feature behind a feature toggle, and then we will eventually get rid of the feature toggle, because we're just trying to see whether test it with a small group of users and then make it available to everybody else.
So finally, one of the other things people mention as putting them off continuously releasing, apart from the possibility of breaking stuff, is aren't we always getting in each other's way? So obviously, as the team grew, then there's more people trying to deploy the code at any one time. So that did start happening, and we considered using a CI server or something, a kind of a complicated system to work around this and manage it for us. What we eventually settled on was a mutex, and his name is Paddington. So I'm on Team Marmalade, so the obvious choice for this was Paddington. And he is basically a cuddly toy, and you aren't allowed to deploy the system unless you're holding the cuddly toy. So it's quite a lo-fi solution. But it's worked really well for us. I did think about bringing him along today, but I realized the rest of my team is still coding today, so they wouldn't actually be able to deploy the system, so that wouldn't work very well. So instead, we have a picture.
Okay, yeah, and this is, we carve our code base up in a way so that different teams are able to deploy different parts that they own, and so there's not just Paddington, there's a bunch of other deployment tokens around, but it might be surprising to you, but actually this is not a practice unique to our company. I've been to work with other companies where they also have various other deployment tokens, such as penguins or dinosaurs, and so it is kind of a common industry practice. So we wanted to kind of, we wanted to talk to you to kind of wrap this up. We've kind of talked a little bit about extreme programming practices that we use, and we wanted to give you top 3 tips that you might use even if you're not in an extreme programming environment. So the first one is?
We thought that it would be helpful to add monitoring. So I'm sure a lot of you already have it, but if you don't, it's a really valuable part of how we work. So it's really, really important if you're going to do continuous delivery. But even if you aren't, I'm sure as web developers, we know that we've got a huge number of systems and platforms where our code might be running, and we need to know that stuff is working there. It's great now that a lot of browsers auto-update, but that does obviously mean that the platform's kind of changing under your feet. So even if you're not changing your code, where it's running is changing. So we use monitoring to work out, to have a sense of the health of the live system.
Sorry.
We're running out of time, sorry. So I would just say that the important thing to do here is to add just maybe one quite generic health check, and then that can inform which ones you need to add to get a better sense of the health of your live system.
So then another thing that can be very simple to start off with is when you're fixing a bug, that's an ideal time to write a test. So you can write a test to prove the behavior is not there already, and then write the code to make that test pass. So you can approach bugs fixing by doing it test first.
And what's great here is that in order to fix the bug, you have to work out how to reproduce the problem. And then once you've got a good sort of set of steps to reproduce the problem, then you basically have already written a test. All you need to do is to turn it into whichever language you're going to write the test in. So this is already, a lot of the workflow is already there. It's just a question of sort of codifying it, and then you get all the benefits of having it tested.
And then lastly, we wondered whether it might be a thing that if you are doing code reviews, I don't know, who has seen this video, Spooning? Which is kind of a spoof on pair programming. You can check it out, it's a funny video. But we thought that with code reviews, you could actually, when you've got a list of changes that you're going to make, that you could do it as a pair.
So you're already doing a lot of the stuff that you would do whilst pairing. You're already discussing the implementation and figuring out what to do next. The only difference is if you were doing a code review, you'd split up at that point, and one person would go away and actually implement the changes. So we thought, as you're already sat together, this would be a great time to try pairing. So the two of you remain together whilst you're implementing whatever the follow-up is. So if either one of you didn't understand what you discussed, this will come out as you try and pair on it. And as you're already sat together, it's quite a low commitment way of trying it out. You know, you're already doing a lot of it, so that could work really well.
And of course, we don't mean that you have to have physical contact to do pair programming. So we're going to wrap this up now. And in summary, we wanted to just explain that extreme programming is about turning the dials up on good practice. So if you have some good practices in your environment that you think would help you to deliver your changes more quickly, then consider ways to improve on those.
It can take a while to get used to them because a lot of them potentially seem quite counterintuitive, but they've been working really well for us, and you can add them incrementally and just try them out and enjoy coding at the same time.
Yeah, okay. All right, so that brings us to the end of our talk about extreme programming. So thank you very much for listening, and we'll be available for questions in room AMA1 at 2 o'clock. Okay, thank you.
Thanks.